Okay, so I'm going to go over the solutions for the radical async lesson. It was pages 14 and 15. And we're going to think about StatMap while we solve. So we reverse order of operations. So for 1a, I have addition, so I'm going to subtract 2 from both sides. So then I have the square root of x minus 1 still equals 3. To undo a radical, I need to do an exponent. So I'm going to raise this to the second power. And then I'm going to go over here. X minus 1 pops out. 3 times 3 is the number 9. And then I'm going to reset, so add 1 again. So x equals 10. If you want to check, you would plug it back in for x. So square root of 10 minus 1 plus 2, does that really equal 5? Square root of 9 plus 2, 3 plus 2 equals 5. Yeah, it works. Okay, let's look at the next one. So this one has a little bit more more things going on. So first I'm going to check addition or subtraction. And let's use a highlighter for a second. So I have 1, 2, 3 separate things. We call them terms. So first I'm going to add 12 to both sides. So then I have 4 times the square root of x plus 1 equals positive 4. Okay, so this step is important, and a lot of students, like the first idea is usually to combine the 12 and the 4, but one is being added or subtracted and one is multiplying. So they have different inverses. So because I have 4 times this square root, I'm going to divide by 4. So 4 is gone. Let's go over here. So now I still have the square root of x plus 1 equals 1. So I'm going to do exactly what I did in part A. I'm going to square both sides to get rid of the square root. So raise it to the second power. So then I have x plus 1 equals 1. 1 times 1 is 1. That's why. And then minus 1, minus 1. So x equals 0. Okay. Same thing, you would check that by plugging it back in for x. All right, let's do the next one. Okay, so same thing. I have a multiplier. Let's use the highlighter again. So I have this whole thing, that's one term, here's a second term, and then it's set equal to one term over there. So first I'm going to subtract 4. So then I have 2 times the square root of 3x minus 2 equals, what is that, 12? So now I've done my addition or subtraction. Now I'm going to do division or multiplication. So I'm going to divide by the number in front of the function. So 2 times, right, the square root. So it's divide by 2. We have the square root of 3x minus 2 equals 6. Okay. So the next step to get rid of the square root, so like again, moving through my checklist, addition, subtraction, multiply, divide, radical or exponent. So I'm going to square both sides. So now I have 3x minus 2, like plops out, set equal to 36. And then I'm going to reset. So I'm going to add 2 to both sides. I think this one is a fraction, which is fine. 38, divide by 3, divide by 3. So x equals 38 thirds. We could just leave it as a fraction. That one isn't going to be too bad to check because the 3's will sort of cancel out. So let me just show you what I mean. I don't have space to do it all. So 2 times 3 times 38 thirds minus 2 plus 4. Does that really equal 16? So when you go to do this 3 divided by 3 is 1. So then this turns into 2 times the square root of 38 minus 2, which is 36, plus 4. And that does work, because square root of 36 is 6. But, so you would keep doing that. All right, challenge. I know some students were trying the challenge, which I love and appreciate. And so let's do some magic. Okay, so same thing with SADMAP. I don't have any addition or subtraction. I don't have any division or multiplication, so I'm going to move right to my exponent, my radical exponent situation. So to undo this square root, I'm going to square both sides. So I'm going to have x plus 2 equals x squared. Yeah. Okay. So hopefully at some point you remember doing this in Algebra 1 2. If you don't, that's totally fine. I'm going to subtract everything at once. Let's use black. So now we have x squared minus x minus 2 equals 0. And I would solve this by factoring. So, yeah, I know. So I need something that multiplies to be -2 and is a difference of 1. So I'm thinking it's -2x plus 1 equals 0. Does this hopefully look familiar to you? And so then you have 2 solutions that are possible. So to make that equal 0, x has to be equal 2. To make the second factor equal 0, x has to be -1. Yes, 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 yes. So I think that I know I saw some students who got x equals 2 just by like plugging in numbers. And then x equals -1 is sort of that other part of the parabola, right? So you have -1 and 2 or whatever. So that's okay if you didn't get that. This we're going to review later. And if you're not remembering how to factor, again, we'll do that later, but that's like a quick Khan Academy sort of thing. Okay, so this one's different or like harder, more challenging. Because why? Because because there's an x on both sides. Because there exists an x on both sides. So that's right, we got like x squared happening. Anyway, just something you can do. All right, a general strategy for anything that looks like this. What is a typical number of solutions for these types of things? That's a great question. Is it possible to get more solutions than typical? Oh my gosh. Well, if we just look at the challenge. Fewer. Because you have no solution, I wonder. Interesting. So something that hopefully you're thinking of is that like if you have A, so like, well, actually I want to start with my K. So if you have K, so like you would add or subtract K first. Yeah. And then you shouldn't have to multiply, but you might have to one day. But you're going to divide by a second. And then if you have the square roots, so then you would like take the square of both sides. And then the h, and these are all like different components of the function we'll see in our graphing unit. So then you have to like plus or minus h last. Oh, I guess I should say third. And that would be fourth move. I don't know. What is a typical number of solutions? So far we've been getting 1. Is it possible to get more than one? Yes. Like, C challenge. Oops. Fewer than typical solutions. We haven't seen any of those. Maybe. Sometimes there's no solution. Remember? But generally we'll have a solution. Okay, so number 2 is, oops, close. So number 2 is the one that was on page 15. Everything else was on page 14. And I hope you, and that it wasn't too horrible. All right, bye.